Hey, Jeff Middle Algebra 1 students. This is Mrs. Fike from Oakland Middle School, and I hear Mr. Schrader's going to be out for a while, so I thought I'd help you guys out so you can keep moving along with your algebra. So I'm not exactly sure where you're at, but my kiddos are talking about solving systems with substitution. So this video is to kind of help you get started with that if you haven't already learned it. So if you've already learned it, great. This is a review. If not, pay attention. I'm sure Mr. Schrader would have put together some lesson that would be similar to what I'm going to show you here. So when we're solving a system that's two linear functions at a time, we're trying to figure out where they're equal. So when we use substitution, we need to think about, well, what does the word substitute mean outside of the math class? So you might be thinking of a substitute teacher where you have a teacher replacing something, or replacing your normal teacher. You might be thinking about substituting at a restaurant when you would substitute French fries for the mashed potatoes, etc. So you've heard of the word substitution outside of the math class. All it really means is to replace something with something else. So that's essentially all we're going to do when we solve substitution. And you guys have already done this in a very small way already this year. So, or even last year in middle school, or in 6th and 7th grade. So, for example, if I give you 3x plus 7, and I tell you that x is equal to 5, you would substitute what x equals in for, or we would substitute 5 in for x. So it would be 3 times 5 plus 7. So we'd have 15 plus 7. That would be 22. Now you guys have already done that. That's a small form of substitution. We call it evaluating, but it's a very small form of substitution. So likewise with this one here, we can substitute what y equals, which is 10, in for y, and evaluate. So we would have 5 times 10 minus 7 would give us 50 minus 7, which is 43. So that's old news, right? All right, so let's up. This time, instead of substituting a value in for your variable, we're going to go ahead and substitute an expression. So here's one. So instead of y, I'm going to substitute what y equals in. So I would have this 3x just goes along for the ride. And instead of y, I'm going to have plus 5x. So 3x plus 5x, that would be 8x. So the next one, we have the expression 3x plus 2y. I tell you this time that x is 3y. So I can substitute what x equals in for x. So I would have this 3 right here, so 3 times 3y, and then just add the 2y. So that would give me what? 9y plus 2y, and that would be 11y. So we're still not up to solving a system yet, but we're getting closer. Oh, maybe we are. Okay, so we are ready to solve a system. So here we go. I see that y is equal to 3x plus 2. So what I need to do is plug in 3x plus 2 for y. I'm going to substitute what y equals in for y. So I'm going to just start writing the second equation down how I see it. I have x plus 2, and now that I'm at y, I'm going to plug in what y is equal to. So that would be 3x plus 2. And now I'm going to finish up the equation of equals 11. So now this should be old news. We know how to solve this. We're going to distribute the 2. So we have x plus 2 times 3x is 6x. 2 times 2 is 4. We're still equal to 11. If I combine my like terms, I have 7x plus 4 is equal to 11. Subtract 4 from both sides. I have 7x is equal to 7, so x is equal to 1. Now, this is good. We know what x is equal to, but a system is the point, the coordinate point, where two linear functions cross. So we have the x value, but now we need the y value. But the good news is we're going to substitute again. If we go back up to this original equation up here, we knew that y is equal to 3x plus 2. And now we have another piece of information. We know that x is equal to 1. So now I'm going to plug in what x is in for x here. So I would have y is equal to 3 times 1, because that's what x is, plus 2. So y is going to equal 3 plus 2, which is 5, which gives me the solution of 1 comma 5. So that would be how I would use substitution to solve that system. So let's look at another one. So this one, same idea. I know what y is. I know that y is equal to 2x minus 3, and I'm going to plug that in for y of this equation. So I would have x plus 3 times whatever y is. Well, y is this right here. So 2x minus 3, and that's still equal to 5. And I get that from just finishing out that equation. So then I would distribute. And so you would have x plus 6x minus 9 is equal to 5. So 7x minus 9 is equal to 5. 7x is equal to 14. So we get x is equal to 2. So like on the last one, we know what x is, but now we need to figure out what y is. So we're going to plug in x equals 2 in for this equation right here. So we would have y is equal to 2 times 2 minus 3. So that's 4 minus 3, which is 1. So I get the coordinate point 2 comma 1 as the solution to this system. So we're going to skip that one. Let's look at this one. This one is a little different because this time I told you what x is equal to instead of what y is. But we're going to approach it the same way. It's just instead of plugging this in for x, instead of plugging this in for y, we're going to plug it in for x because that is what x is equal to. So we would have 2 times 6 minus 4y minus 3y is equal to 1. So we would have 12 minus 8y minus 3y is equal to 1. So 12 minus 11y is equal to 1. If I subtract 12 from both sides, I get negative 11y is equal to negative 11. So y is equal to 1. Now, just like on the other ones, now we have to go find x. But we would have x is equal to 6 minus 4 times 1, which would be 2. So I would have the coordinate point 2 comma 1 as my solution. The only way that this is trickier is if I have two equations like these written in standard form, and I would have to rearrange one of them in order to get a variable by itself. So what I would do is look at them and say, I want to think smarter, not harder. What is the easiest way to rearrange one of these equations? And I think the top equation is probably the easiest one to do. And I think getting x by itself would be the easiest way to go about it, just by adding y to both sides. So we really have x is equal to 3 plus y. And now we can plug this in for x of this equation. So that would look like 3 plus y plus 2y is equal to negative 6. So 3y would equal to negative 9. Y would equal negative 3. And then if I plug that back in, I would get x is equal to 0. So I would get this coordinate point. I know I went through this really fast, but I believe that you guys have already learned this because I think you guys are a week ahead over there at Jeff Middle than we are at Oakland. So hopefully this was a review. We'll give you some practice to work on, and hang tight until Mr. Schrader gets back. Peace out from Oakland.